Good morning, afternoon, depending on where you are, everyone. It's just about 9 o'clock, so we'll give it one more minute or so, and then we'll go ahead and get started. All right, why don't we go ahead and dive in? I see a few people trickling in, but it is about 1 past now, so I want to make sure we get started on time so that we can wrap up and get you along on your day. My name is Heather Gadno. I'm the VP of Marketing here at Gemini Data, and I'd like to welcome you to today's webinar, Faster Investigations with AI. Our speaker today is Mark Seward. Mark is a senior content strategist with Gemini Data and is an integral part of the marketing team. He has over 20 years experience in technology and was previously a security analyst, so he has a lot of experience with the pain and the challenge of investigations. Mark's also held positions at Splunk, Exabeam, Symantec, and Anomaly. Before I turn it over to Mark, I just want to touch on a few housekeeping items. If you have any questions as we go through the webinar, please type them in the chat screen. I am going to mute all participants just so we can keep the noise level down. And we'll address those questions either as we go through the presentation or after the demo at the end. So with that, I'll hand it over to Mark.
Well, thanks, Heather, and good morning again, everyone. Just before we get started, I want to make sure that you know a little bit about who we are. We're Gemini Data. We have a sort of a global distribution technology partner network that includes Splunk, Cloudera, Dell. And our mission was, when we started the company, our mission was simplifying big data platform management. All of our customers were spending a tremendous amount of time on and resources on technology and subject matter experts on big data platform management. And they needed a simpler way to deploy, manage, and extract greater value from their investments. But what we found was that as we started talking to our customers, they helped us realize that really big data management was only one part of a much bigger problem. Analysis of the data in their big data platforms and analysis sharing were also problems. They were cumbersome, inefficient, and really prevented the realization of the full value of their investment. And that really leads us to what we call the 3 barriers to organizational awareness. In other words, you're not really able to solve the problems of data analysis because your management of big data solutions is expensive and complex. The analysis process is really full of redundant steps, and I'll show you what that looks like later on as we go through some of these slides. Communicating problems between line of business owners and IT is really too difficult. It's almost like IT line of business owners are from Venus and you're from Mars, and you're trying to talk to each other and in most cases talking past each other. So as we look at these problems, we'll address these with Gemini Enterprise, which is in a category all its own called continuous data analysis. We're continuously going to be analyzing data and pre-analyzing that for the investigator or for the person doing the analysis. So the whole stack, or what we call the full stack solution that addresses all of these problems, looks something like this. We're automating machine data, bringing in machine data, security data, operations data. We're automating cluster management. We're automating configuration of nodes and fine-grained configuration of all of that. We're providing an AI-driven solution for analysis, which is really important, and that's what we're going to be demoing today, so I'm not going to spend a lot of time on that part. And then finally, we're going to be talking about how to make analysis a corporate asset by sharing stories. Obviously, we've got lots of people who are stakeholders in what happens in IT in the organization, all the way from the CIO all the way down to the analyst. So all of those different layers need to be able to communicate, and shared stories is a solution for that. So what we offer, just very quickly, again, this presentation is not necessarily about Manager, but I just wanted to make sure you're all aware of what we have in this particular area. We are simplifying data management for analysis by allowing you to have single-click deployment and automated management of data platforms. It's a turnkey solution that really unlocks value in your platform to support accelerated analysis, and also meet the demands of growing data volumes without any additional operations resources. In other words, what we're doing is, with automation, we're making it so that no matter how much data you put into your system, your management effort remains the same. It stays constant, it stays flat. So we have that part of the product, and I believe we'll mention at the end of this webinar another webinar where we talk specifically about management of data platforms. So let's get right into what the subject of today's talk is about. I call it the Analyst Dilemma, and that we need to use data to tell an accurate story quickly. When you break everything down, that's what the analyst needs to do. We need to understand everything we can about the story so we can communicate that to the people who have to fix whatever we see, for example, and we need to be able to communicate that to line of business owners. That's the storytelling. And then being able to do this quickly, well, there's a lot of obvious benefits with that, and we'll get into those. Here's a look at what analysts have to build a story with. And I know this is kind of an overwhelming slide, but frankly, analysts are overwhelmed with the data. This represents metadata that you would see from email systems, from malware, vulnerability logs. You can kind of see that I've got this arranged. This metadata is all arranged in key value pairs. And it doesn't matter if this data came from Splunk or it came from Hadoop or from ArcSight or someplace else. It's really the data that we're focused on. And you can begin to see, I've marked some of the things in red here that may be common across some of these data sources. Just for grins, we've also got some DHCP logs and some AD logs, and I've also marked in red some of the fields that are common across these 5 different data sources. So what analysts are really faced with is telling a story with this sort of, telling an analysis story. To do that, I'd have to pivot across all 5 of these sources. I'd have to look for common data elements. I'd have to pick the right pivot points. I'd have to supply my own relationships and keep all of those in my head. And I'd have to manually record my thoughts or my analysis. Now, there's a lot of problems with all of that. The biggest one is my brain doesn't scale to be able to do that. If I get an alert from the malware system here, even if the action is violation blocked, I may be curious and want to dig into that. So I see the sender, I see a source IP address, I see a machine, I see a file name here, and then I pivot on the file name to email. I take a look at the logs in email. Maybe I want to look at the IP addresses, and I go to find out who had the lease on that IP address so that I know what machine to look for. Going through all of this is very, very difficult. And again, it simply doesn't scale. So what I've sort of taken a stab at is putting together the current state of the analysis process. And I've broken this down into 4 steps that analysts take when they're reviewing this kind of data to try to analyze it and tell an accurate story or create analysis. The first thing I have to do is I have to decide what data element in a log to focus on. Maybe an MD5 hash or an email address, an IP address, some other data artifact perhaps. I have to do that first. Next, I search for that element across all of my data sources. I want to find out where else that data element may have appeared. So I search next. Then I will pivot to another data source that may contain the original data element, or I may use a different one to continue my investigation. So there's a pivot step. And then I review the results, and then I decide, search, and review again, over and over and over again. And I'm usually having to follow a single hypothesis or a single analysis thread, hence the name single-threaded analysis. And there are issues with this. There are lots of possibilities or lots of chances for false starts. A wrong choice can simply send me in the wrong direction. There's no context for the decision making. I have no sort of context with what I'm working with. I'm simply following breadcrumbs. After 4 cycles, it's really difficult for humans to keep all of this in their brain and try to get back to a particular point. And that means that analysis is often driven by educated guesses or hunches. Not the best way to do this. Sort of an analogy I've been thinking about is if you're the quarterback and you were going to be in a game, and I gave you a pair of glasses and I narrowed your vision only to certain sections of the field, and you had to decide whether you were going to make a pass down the field by just seeing a tackle, the center, a defender, and your receiver. And then you do that over and over again. You shift to the next vector and you look at that area. You shift to the next vector and you look at that area. And in reality, quarterbacks don't work that way. They scan the whole field all at once. They take in as much information as possible, as quickly as possible, so they can make the right decision. So we're really quarterbacks with blinders on when we look at the single-threaded analysis or the current state of the analysis process. This also, sort of an ancillary problem to this, there's also issues with knowledge sharing. Today, when an analyst actually tries to create a story from that analysis and try to document it, the analysis itself ends up being preserved in a ticketing system or in Box or Google Drive. And frankly, it's less likely to be used for reference in current investigations. And I call this too much distance between analysis tools and saved completed analysis. If I want to work as quickly as possible and I need to get to the bottom of something really fast, having to hunt down the right analysis that may be analogous to what I'm working on in a different part of the IT infrastructure, it's probably not going to get looked at or not going to get used, let alone the fact that if Bob created that analysis, I might have to track down Bob to find out what the heck he meant. So that slows the whole process down. The second thing is that verbal sharing of IT outages and security incidents really doesn't work very well. It's kind of like a game of telephone tag. I'm going to tell my manager, who's going to tell the line of business owner. The line of business owner is really not as tuned into how this happened. He's more tuned into, or she's more turned into, how this affects their business. And the technical analysis is often lost on them. So verbal sharing of this kind of thing is really not working either. People are experiential learners. Scientific studies tell us that about 70% of learning is experiential. If I have to learn by rote, by reading someone else's comments about analysis, it's not going to be as effective as if I could replay the analysis itself, see what the analyst did, and figure out, okay, that's what they did in this circumstance. Maybe I can apply that knowledge to what I'm doing now. So lack of replay is also a big problem when sharing analysis or taking a look at analysis. And then finally, analysis documentation is really inconsistent. Every analyst out there has what I call their own documentation accent. I might use terminology when I describe an incident or a service outage that is unique to me. The next analyst is going to do the same thing, and so on and so forth down the line. This means that this inconsistency in lexicon really makes the analysis harder to share, both across analysts as well as with line of business owners, because they're hearing something different from different analysts all the time. So if we look at analysis and that step in the process of figuring out what happened, really there are 5 key problems. Log data really forces analysts to think only in key value pairs. It's really almost impossible to communicate in that format without some level of ambiguity. Your SIM and UBA tools really aren't focused on telling you the relationships between data elements in your logs. That's not what they were built for. That's not what they do. So really no information about relationships is really provided. There are cognitive biases and intuition analysis that really allows for mistakes in reasoning, evaluation, or remembering a situation. And these biases are really caused by too much information or information overload and not enough meaning. The need to act quickly and the limits of memory also drive these kinds of biases. Your brain simply doesn't scale. If you have a piece of analysis work that's going to take 14 steps and you end up at the 14th step and you haven't figured anything out, you've gone down a rabbit hole, how do you get back to the 7th step and start over from there? There's really almost no way to do that. And then finally, it's really time consuming. I mean, root cause analysis in some cases can take days or weeks. It's pretty easy to pivot your way down into the wrong place. And your SIM, your UBA solution isn't going to help you with communication problems, with sharing analysis. So with that, let's take a look at Gemini Enterprise and see how we can transform analysis with AI. And with that,
so Mark, while you're making that transition, just a quick note, there's some rattling from your end. So if you could keep that to a minimum, that would be a little bit less distracting. Thanks.
Sure. Hang on just one moment. Okay. So this is the interface for the investigation portion of Gemini Enterprise. And don't worry, it's not complicated. I'm going to walk you through it. The most important thing you can first note here is that we have a canvas right in here. It's a blank canvas on which the investigator can perform their analysis. So we're going to start here, and we're going to work our way through the entire product. Don't worry, I'm not going to skip anything. But we're going to show I'm going to show you hopefully 2 different scenarios as to how this works. The first one is we're going to take a look. I've got a time range here of all time. I'm going to look across that, and I'm going to look for, we're going to triage an alert, which is one of the many use cases that this is helpful with. Triaging alert, threat hunting, determining root cause analysis on the operations side, fraud, lots of different things can be addressed with link analysis, which is actually what we're doing here. So let's take a look at this. I'm going to start with this McAfee endpoint security alert. And already you can see that that's come up here on my screen. I've got a little card that describes that this is indeed a McAfee endpoint security alert. And we're just going to go ahead and click on that. And what our system is going to do is tell us a little bit about that alert. And already I know that this is a host intrusion detection. This is the detection itself. And this is a relationship. This line represents the relationship between these two elements. So I'm going to click on my blocked attachment, and you're going to note that the system has taken the key pieces of metadata out of the alert and is showing us a vulnerability, a backdoor software installation, and a file name. So it looks just at first glance like, you know, if, most people have enough skill to take a look at this and go, it looks like this alert was probably around a malicious file, and it was an HTML file, so it probably is some kind of attachment that McAfee Endpoint Security has seen. But let's dive into this a little bit further. Let's take a look at the attachment. And again, about the attachment, we've got all of the elements, the key pieces of information that we need at our fingertips, and these relationships are inserted into the analyst path between where we are and where we want to go. We want to be able to find out as much about this particular file as possible. So if we read we've got a story forming right in front of us here, and let's take a look at what that is. We've got an email, and it had an attachment called the 2016 recruitment plan. It's located, the recruitment plan file is located in this particular directory, and it has content that is this malware script. So we're beginning to start a story forming as we do our investigation. And let's find out a little bit more about the email. And again, what's happening here is that machine reasoning, or AI, machine reasoning is a form of AI, under the covers, is assigning the right relationships between the data elements in our log data. So when we look at that, in the next step here, where I've clicked on the email itself, I've got, okay, the recipient was this email address, and the sender was this email address. And actually, this is kind of a good thing, because if there were hundreds of recipients, all of those email addresses would have shown up. But it looks like there's only one email recipient for this, from this particular sender. And if I want to know more about the sender, because we have Active Directory logs in here, as well as a wide variety of logs from Splunk, from AppDynamics, from Cloudera, a wide variety of data that the system has read and established relationships for, I can click on the email address, and I can see that this is from Robert Dobbs. He sent other emails during that particular time period. And if I look closely at him here again, I can see he's in the Dallas office, and he's in this particular business unit, this US sales outlet. So I know about Robert Dobbs a little bit. I know he sent this email with this attachment that was blocked by McAfee, and it was a McAfee Endpoint Security alert. But let's dive into this just a little bit further, just to complete our story. And this script that was in the recruitment plan has an MD5 hash. And again, if this MD5 hash was prevalent in any other log, I would see this MD5 hash replicated multiple times. So I know also from this that whatever this is hasn't spread. It only went to one sender. And then finally, if I want to know more about the vulnerability, I can click on that, or I can go to the backdoor and find out that this is Dooku variant 2, and it's on Robert Dobbs' machine, which is owned by Robert Dobbs. So here's my story I've just created with the help and assistance of AI. I haven't done any pivoting. I haven't done any searching. I've essentially skipped those two steps in the current analysis process. And I've created a story that now is time to share. And I have ways that I can share this. I can certainly share this as a shareable link. I can select any user I want from here and share it with them. Maybe it's a fellow analyst, or it's a line of business owner, or maybe it's an alias of an entire department if I wanted to. I can create that story. I can name this, save a story thumbnail, add a description, and again, share this with selected users if I want to do that. I've got some stories created we're going to look at later, so I won't do that here. And because the AI system or Gemini Investigator uses a data ontology that's consistent, every story uses the same terminology, the same relationships: recipient, sent, file installed by. All of these relationships mean that my story, when it's shared with somebody else, is going to be consistent, no matter who the analyst is. So with that, I'm going to go over here to the left, and we're going to take a look at our stories section. Now, our stories section, it contains the knowledge of the analyst. It really treats analysis as a corporate asset that can be reviewed. I can see that this particular bit of analysis, this story was created by Conrad, doesn't have any comments yet. I can favorite that if I want to. I can edit the story if I need to, or I can look at a detailed view. I can also open this up if I want to learn from what Conrad did. And he created a story that looks like this. I could go into the comments section that Conrad had, and I can take a look at how he got to his particular conclusions. So with stories, what we're able to do is show a wide variety of stories. We're able to categorize those stories by what we call channels. These channels represent different categories so that I can subscribe to those. I can look at my favorite, or I can just look at mine, or I can look at shared stories here. And again, I can share these with whomever I need to share them with. We also have a dashboard which talks about all the activity that is that's going on. And here's current story activity, people viewing these stories, using those to make decisions, looking at the top searched elements, top updated elements. We don't have any of those yet. I'll show you how that works in the next scenario that we take a look at. And then, of course, we can take a look at search activity. And by selecting some of these, I can pick up where someone else left off. If I've got a particular story that's clickable, I can actually resume work on it between when I left off and the next time I visit this particular tool to go in and take a look at the stories. Our inbox is really the hub of our notifications. So this is where I would learn that Simon shared his story about a suspicious email attachment, or a Splunk search head that couldn't be reached by an indexer. And then finally, I have obviously configuration, so I can go in and take a look at configuration of users, figure out what messages I have coming in, and look at those from a variety of different sources that I have for my particular investigator. So with that, I'm going to go in and take a look at another investigation scenario, which is more on the IT operations side. So we will take a look at that. I've been getting a large number of alerts around average transaction speed. And so we're going to analyze this IT ops, or application performance management scenario. So as I search for alert, you can see I've got a lot of these alerts on average transaction speed. If I click on one of these alerts, I see this is from App Dynamics, and there's some sort of health rule violation of my application. And so I know that I've got some sort of application performance issue already. I've got a lot of alerts around that. Let's see how they're connected. Okay. I've got a lot of connections from all of these different alerts. I've got the alert I selected down here at the bottom, but they're all related to this average transaction speed detective control. And that's where I really want to get to start to my investigation. So I'm going to select that. And I'm going to isolate that particular control. And let's dive into that. Okay. And so when we do that, it's a part, I see it's part of a daily performance monitoring rule in App Dynamics, and part of a set of rules. It's a policy, and this is a detective control. So let's again dive into the policy. Going to isolate that. All right, now let's take a look at what this policy governs. Okay, so this policy is governing Magento. Magento is a common web store or web sales platform that lots of people have installed. And because our average transaction speed detective control caused all those alerts, I probably have something wrong with Magento. So let's dive into that. Okay, Magento consists of failover, backend, and front end. And if it's average transaction speed, I am allowed to use some logic here. I'm going to start on the back end because usually transaction speed means there's some sort of processing issue that's causing things to slow down. So if I look at the back end, I can see that the back end consists of a master and a slave, but it also is part of a Postgres SQL database, and so we're going to dive into there. Okay, the database runs on this particular host, and it contains this particular port number. And just like our previous demo, we can see that this database is configured to use this particular port number, and this particular database is installed on this particular host. So again, AI is at work inserting the relationships for us here to make sure that we're seeing the data elements that are related to the elements that we're looking at, and ascribing those relationships so that we can use them on our analyst canvas. So I'm going to dive into the port number because that was what was brought up by the system. And already I see 2 failed connection errors right here, and I see an ACL entry related to this particular port. And so let's start with the ACL entry. Usually I start with these 2 errors, but I'll go into the ACL entry and point out that's part of a network ACL. Has to do with network topology. Okay, and it looks like that network ACL was affected by a recent change. We see remove additional open ports. So that's actually a reconfiguration request that we've gleaned from log data that AI has pulled out for us here and shown us, along with a number of other changes that have occurred. If we look at this reconfiguration, we can see that looks like Mr. Atkins, Charlie Atkins, who is a domain admin, performed an action to remove additional open ports. He did all of this work. He also changed a rule here that changed this port or altered the ability for traffic across this port to go through. And that caused a couple of errors against our Postgres database, which was on the back end of Magento, that was monitored in our policy for average transaction speed, and that was causing all of our alerts. So again, our story is beginning to come together. If I look at these 2 connections, I can see that I have some failed connections from these IP addresses, and I can open both of those up. And so 21.30, 21.31, and 22.12 are all problematic for us. They can't they can't reach the database. And so we can go ahead and open those up. And so we've got, this one happens to not be able to reach the database from the web side of Magento. So in other words, somebody is trying to perhaps buy something, put it in their shopping cart and purchase it, but these connection errors are not allowing them to do that on that side. And then if I look over here, I can see also Web 2 is having a problem. That's also related to this error. And then finally, I can also see that I've got connection issues on the subnet. And that's a network traffic issue that is likely caused, again, by this port and this inadvertent rule change that's caused us problems, as was done by Mr. Atkins. So in short order, we've taken hundreds of alerts and sorted those down into just what we need to see, which is our policy around slow network traffic or application performance monitoring, and we're able to bring all of that together. And I can sort of select which part of this I want to take a look at if I need to. I can, again, all of the relationships are placed here for us so we can see those. One thing I didn't talk about in the prior security demo was the fact that Gemini Investigator Gemini Enterprise has been tracking our movements. So this is a sort of a more complex scenario. So if I want to go back to a particular point and walk somebody through it, I can actually do that. I can show someone what I did, how I reached the conclusions, and how I built out my analysis graph on my analysis canvas to be able to tell a story. So I've got those sorts of things. I've also want to quickly show you a little bit about why we're able to cross domains from operation to security. A lot of solutions, graph analysis has become fairly popular, and a lot of solutions out there are focused on security or IT operations, or maybe fraud, or looking at compliance. And those are built around specific domains and specific domain terminology. What we did was we looked at the way knowledge is curated and collected and classified by the brain, by people. And people classify their data or their knowledge into entities, events, locations, sets, and states. Entities are people, places, and things, for example. Events may be an alert or some sort of other thing that you're told about. That's an event. A location is, of course, Somerville, California. A set is a grouping of things that, elements that have things in common, like vulnerability. Lots of hosts might have a particular vulnerability, and that would be a set. A state is basically the state of something is in at a particular time. It's time bound. So these are the way that we started classifying data from the very beginning when this was built, so that it could be used for almost any kind of use case. You can certainly dive into the relationships and take a look at those. We're not going to do that today. You can take a look at the elements and dive into those and just look by element type if we want to. But for analysis, I hope I've shown you two different scenarios that indicate the power of using machine reasoning and AI to short circuit the analyst process, to make analysis quicker and hopefully more accurate. And with that, I will turn it over to Heather, and hopefully if you have some questions about what I've just shown you, because it looks like magic, it's really not. It's the power of AI and machine reasoning. So with that, I'll turn this over to Heather and see if we have any questions from those folks out there in the audience.
Great, thank you, Mark. We do have some questions around deployment models.
Mm-hmm.
So can you talk a little bit about how this technology can be deployed within an organization, whether on-prem, in the cloud, is it SaaS, etc.?
Well, I think you just answered my question for me. Yes, it can be deployed in the cloud. We are developing private cloud offering. It can be deployed on-prem. It can be deployed wherever it needs to be deployed based on what you want to monitor. And certainly in a hybrid environment as well, where you've got applications in the cloud that you can collect data from, maybe through CloudTrail, and bring that data into the system for analysis alongside data from servers and hosts at your premises, for example, and create a story that links all of that together. This is really important when you're thinking about identity and access management, where you've got you want to try to understand who's trying to connect and see what data, and they're going through some sort of a cloud-based solution like Okta, for example, or Ping, one of those.
Great, thanks. And the only thing I'll add there is that you know, the hybrid solution and the private cloud solution and on-prem solution were really developed so that we can ensure security of data for our clients and customers. There are you know, some organizations out there that we're working with that are on their journey to the cloud. They're not quite ready to you know, port all of their data to the cloud. So what that allows us to do is really host the solution and keep the data on premise, while only sending certain types of metadata to the SaaS component of the Investigator solution. So it really increases security and makes sure that data falls in line with different security policies and practices within each organization.
Thanks, Heather.
All right.
What next?
I don't really have that many questions from the audience. If you do have any questions, please go ahead and type those in now. Oh, here we go. All right. Can you talk a little bit more about the stories function and how that is beneficial to an organization?
Sure, sure. Well, as I mentioned earlier, making sure your analysis is all in one place. If you create analysis, what happens to it after you're done, after you've reached a conclusion? Where does it go? Does it go in a 3-ring binder and get put in a file cabinet? Does it go into Google Docs? Does it go, where does it end up? And is it accessible? And can people actually reuse it to either share a story with a line of business owner or a CIO or the rest of the analysis team or a security team, to let them know that, hey, next time, you know, watch what you're doing as far as configuring, you know, ports on a switch or something of that nature. So there's plenty of uses for the stories. The stories also are a authoritative system of record. Often auditors will want to know whether or not you have a robust incident response program. Certainly, the stories will help with that, because it not only indicates that you have some way to assess and respond to an outage or a security event, but also that you're following particular processes, which is really important. And then finally, what this does is it really makes it so that in the middle of the night, if I'm on shift, for example, in the middle of the night, and I'm trying to analyze something that is happening on my network, either a security event or an outage, I have at my fingertips the total knowledge of the rest of the analysts on my team. And I have the ability to take a look and say, okay, what did Bob do? What did Heather do under this particular circumstance? How did they formulate their analysis? I just want to replay to see what they did. It up-levels all of the team members to be able to have analysis fully documented and visualized that I can replay and that I can learn from. Do you have anything else you want to add to that, Heather?
No, that's great. Thank you. We do have a few other questions that came in.
Good.
One is regarding existing systems that create logs. So for existing systems that create logs in their own environment, how can this solution be applied? So it might be good here to touch on our ecosystem partners and how we actually integrate with various log solutions.
Sure. So what we focused on, we've got a variety of different connectors for specific strategic applications, like Active Directory, for example, or with App Dynamics. But we also take in any data that you want to bring in from Splunk or Cloudera as well, or from a Hadoop-based solution. So we're taking a look at all the data that's been collected. We don't necessarily want to create a separate data lake from those that you've already got built. So what we're doing is we're drinking from those data lakes constantly, pulling in that data. The system, even when you're not using it, the system is analyzing that data, inserting relationships between all the data elements in the logs, and then allowing you to work through on the analyst canvas to see how those relationships can help you tell a story, or how those relationships can get you to root cause analysis or understand a particular security incident, for example. So bringing in all of that data from those particular sources, and we're adding new ones all the time, by the way. We can certainly follow up with a complete list of what we've got today and where we're going.
Great, thanks. And just to clarify a few things there, all the logs do not need to be fed to a data lake. So one of the benefits of this solution is that you do not have to port your data or transfer your data over to a different data lake. You can utilize your existing solutions and existing technologies. We really, when building this and refining it with customers and those that are using it in the market, we're really adamant about not creating another thing or another solution that would require you to do a lot of setup or configuration or porting of data. So the real goal of this is, if you need data management capability or assistance, the platform manager component of what we offer allows you to rapidly deploy and easily manage solutions like Splunk and Hadoop, Cloudera, Elastic, and some others. And then you're running those in your environment, and simultaneously the analysis component can sit on top of that, but it doesn't require you to port data or move data over.
Right. Just one last thing, a little bit of a higher level. This is what we did was we took a look at the analyst's problem. So what we're doing is we're taking data in through Splunk and Cloudera and other solutions from detection solutions. And we bring the detection solutions, those detection solutions go into your main log analysis platform, again, whether it's Splunk or Cloudera or other ones, ArcSight too, for that matter, and then look at those look at those and then make this a system that can be used for analysts. So it's not this is really not a detection solution, but it helps you analyze a problem quickly and tell a story quickly.
Great, thanks. And just on that note again, there's a question here about accepting customized log files. Yes, we can work with you to ensure that whatever data you'd like to use with the system is accepted. So that would have to be a discussion that we have, but it's definitely within the capability.
That reminds me, Heather, I really didn't do a good job showing that you can add your own, certainly you can add your own, create your own data elements. You can create a relationship, add relationships if you want to those. So the system is extensible beyond what we have. We've classified over 2,500 data elements and almost 1,000 relationships. So if you think about sort of the infinite combinations of those two things, we've got quite a lot covered across a lot of different use cases.
Great, thanks. So another question is regarding human interaction involved during analysis. So I'm just going to read this out. Is human interaction involved during analysis and reasoning to make sure the result is accurate? Mark, I'm going to let you get into the technical details of this a little bit, but just at a higher level, I'm really excited that you asked that question, because the whole ethos of the brand that we built and the philosophy that we're bringing to this product is fusing human and machine intelligence. And I can go on about how that's represented in the logo and a lot of what we're doing, but we really believe as an organization that you have to have this combination of human intelligence and machine intelligence, not only in order to make sure that accuracy is paramount to the work that you're doing, but also because we want to be able to enable those that are working with technology to be able to do their jobs faster, more comprehensively, etc. So leveraging AI and leveraging technology to give them the tools they need to be more efficient and productive and really increase that knowledge that they have. But by no means do we see this as a replacement for that human element.
No way.
Follow up with that on some of the technical aspects of that, that would be helpful.
Yeah, the human is still the king of context, as I would put it. The human is what is going to know. For example, perhaps the system is not going to know that this particular host is out of service, for example. And I can, as a human, I'm going to know that, and I can actually add that piece of information to this host so that as I dig through my analysis, I can say, oh, okay, wait a minute. This host is down intentionally, or is offline for an update or an upgrade or a patch. So humans know that. The system is not going to know that kind of thing. Humans are essential for being able to figure out what things mean. What the system does is it removes the search and pivot steps that are cumbersome, and it helps point you in the right direction using relationship discovery between data elements. That's what we're providing, and that's how we're augmenting what human analysts can do to speed things up and make things more accurate.
Great, thanks, Mark. This is a question regarding data and storage. So what does Investigator store as its own data for the analysis to work, and what is the ratio from the original data size to what Investigator needs? Basically, what are the storage requirements for the system to work? We may have to follow up with you on this, but I don't have a very detailed answer for the exact storage requirements. Mark, is that something you want to tackle, or should we commit to following up?
No, I can give you a sort of an overview on that. I've been told that we're looking at really only about 15 to 20% of the data. We're looking simply at the metadata. We're not looking at punctuation. We're not looking at all kinds of different fields that really don't have what I would call immediate human meaning. So it's we're not having to analyze every single character in the logs. We're simply looking at the metadata itself. Certainly the timestamps in there, source IP addresses, email addresses, MD5 hashes, all of those kinds of things we're looking at. Anything in there that would be more human readable, which is what analysts do anyway. That's really all they're going to look at. Is they're going to look at if I go through the logs, I'm really focused as an analyst on the metadata. I'm not looking at massive amounts of open parens, for example, in log data, or a 25 or 30 line log JSON log. I'm not going to look at all of it. I'm going to pull out the pieces that are meaningful.
Great, thanks. And I definitely have your question noted, and we can follow up with you on a more detailed to have a more detailed discussion around storage requirements if you're interested. All right. We can also follow up on the licensing model as well. There's some questions here around the licensing model. It's actually not around data volume. So the way that we go to market with this solution is in we're offering one solution that includes the data management component that Mark talked about at the beginning of the webinar, the analysis component, and the story sharing component. So that total solution is Gemini Enterprise, and the licensing for that is brought to market as a SaaS. We also have a hardware appliance for those organizations that want to run the solution on-premise. So if you're interested, we can follow up with much more detail around the licensing model, data volume, etc. So that looks to be all of the questions that we have. I'll give it just a few seconds to make sure nobody has any other standing questions. These are great questions, by the way. Thank you so much for actively participating in this discussion. All right. So with that, we'll go ahead and wrap up.
Actually, Heather,
know that we have recorded this webinar, so we'll be sending that out to you after the webinar. And also, if you're interested in learning more about the data platform management component, how you can easily and rapidly deploy Splunk and Hadoop, and then manage that in an ongoing way, let us know, and we can send you the invite for that. There is a webinar the first Tuesday of every month covering that component of Gemini Enterprise in much more detail. All right, Mark, anything else you want to add?
No, I think we covered a lot of ground. Again, I appreciate all the questions and hope I was able to make an impression that AI can really help you out as an investigator.
Great, thank you. So just to recap, with Gemini Enterprise, you can drive awareness of stories, transform analysis with AI, and simplify data management for analysis. So you can really solve problems faster, increase productivity, and create this common language between business operations and security teams. And with that, I'll thank you all for joining, and we'll send out the recording shortly.